I'm saying 8 interview questions. However, I'm going to cover 8 areas in which you should be prepared if you are writing boosting in your resume. What could be the areas in which you have to prepare yourself? Let's go and see. So guys, here as you can see, the first thing is what and why of boosting. So this is a very normal thing. What is boosting and why it is needed. Then comes compare bagging and boosting. Then comes what to choose for large data set. Okay. Then do you need to normalize your data for boosting? Then advantages and disadvantages. XGBoost versus light GBM. XGBoost versus light GBM versus cat boost versus gradient boost. Important hyperparameters and how to tune those hyperparameters in boosting. All these are different ways to check your understanding of boosting algorithms. Now, I'm not talking specifically about XGB or light GBM or cat boost, rather boosting as a whole. Let's try understanding what and why of boosting is a detailed topic, so I will not go into much detail. Rather, we will start from compare bagging and boosting, right? This will give some answer of what and why of boosting also. Basically, boosting is an ensemble technique, that is a sequential learning process where multiple models are trained one after another. That is your boosting, right? And why boosting is needed? Boosting is needed because we want to have a good balance of bias and variance, and we want to have a good performance from the model. For both these reasons, boosting is a favorite algorithm for many guys. Now here compare bagging and boosting. Let's come here and compare, guys. Very important to understand this concept. So here I will write bagging, okay, and here I will write boosting. So interviewer will try to check if you have the basic understanding of both these things. So what are some of the key differences, guys, between bagging and boosting? In bagging, you will have a deep decision tree. What is the meaning of deep decision tree? Fully grown decision trees. It will not be like, until or unless you prune it, it will not be like one level or two level decision trees. But if you remember, in boosting, it is normally a shallow decision tree. Shallow means it will be kind of small decision tree. It will be kind of, one level, two levels, like that, right? Basically one level that we call as stumps sometimes, right? So this is the first difference. What is the second difference? The second difference, guys, in bagging, right, your decision trees normally have high variance, okay, high variance. Whereas in boosting, your decision trees normally have high bias. Now, both these approaches will try to have a balance of bias and variance. That is the purpose, right? Both these trees will have a good combination of bias and variance. It will not be too high bias, too high variance, but the way it works is different. Here, all the high variance decision trees will be combined to get a low variance decision tree. Here, all the high bias decision tree will be combined to get a high low bias decision tree, right? So these are two key differences between bagging and boosting. And then the normal difference that you know already, no need to mention, parallel learning versus sequential learning, right? So in bagging, all your decision trees will be trained in parallelly, it can be trained, and here it will be sequential, model 1 then model 2 then model 3. Here model 1 model 2 model 3 can happen in parallel. Model 1 can happen, model 2 can happen, model 3 can happen in parallel. Here model 1 happens, then only model 2 happens, then only model 3 happens. These are the key differences between bagging and boosting. This will be asked to you to check your understanding of these two things at high level, okay? What do you choose for large data set? Very important to understand. If you have a large data set, then you go for bagging or boosting. XGBoost in the previous version, right? In the previous version, it had some performance issues. But now with the new versions, XGBoost also has overcome those performance issues, right? And since it is a sequential learning process, right? If you have the large data set, your performance will obviously come down. Since it is a parallel learning process, so your performance will be good here. But mostly boosting model will outperform your bagging models in terms of, when I say performance here, I mean how much training time it will take. Okay. But when you compare the model accuracy, when you compare the model outcome, right, your boosting model will definitely, in most of the cases, will, take the more score as compared to your bagging models. So To keep the long answer short, what do you choose when you have a large data set? If you have the good infra, which you normally have nowadays, obviously your choice should be boosting model. If you don't have the good infra, if you are struggling with the model training time, if you are struggling with the infra, then you will go with the bagging. Why interviewer will ask you this question? They will try to check if you know or if you have used both these models. Okay, let me see the next one. From my notes also I'm seeing, so that I don't miss any point. Now, do you need to normalize the data, right? Do you need to normalize the data? What do you think, guys? Do you need to normalize the data? So in decision trees, do you need to normalize the data? My question to you. Mostly no, but is there a harm in normalizing the data? No. If you're normalizing the data, will it harm your decision tree learning? No. What is the advantage if you normalize the data? Suppose I normalize my data and then I train a decision tree or random forest or bagging, boosting, whatever. And the same data, I train a regression model, linear regression, logistic regression, whatever. What I can do is I can compare the performance of both the models on the same data because both the data are normalized. This is one place where I feel if you want to compare the performance of two models, right? I mean, one regression model, one tree model. If you normalize, you can compare very easily. If you don't normalize, still you can compare, but the data set that is going in the input may not be same. That is one advantage of normalizing the data. Other than that, in decision tree, bagging, boosting, ensemble models, normalizing will not help you to a larger extent. Okay. What are advantages and disadvantages of boosting models? Very, very important to understand. What are advantages and disadvantages? So I will first write advantages here. First advantage of boosting model is higher. You call it accuracy, you call it performance, or whatever you call it. Boosting models will typically give you very good accuracy. Okay. Then you will have good mechanism, internal mechanism I'm talking about, mechanism to take care of data pre-processing. So what I need by data pre-processing is your missing value in the data, your outliers in the data, all these things will be in most of the boosting models, right? This is not a big pain. All these things will be internally taken care by the models. Okay. These are the advantages of your boosting model. What are the disadvantages of your boosting model? Disadvantages. First is, since boosting model, you have a very shallow decision tree mostly. So what may happen is it tries to reduce the gain the maximum accuracy. It tries to improve the model after model after model, right? So if you have outliers in your data, right, it may get impacted. It may get impacted by outliers. Why? Because model will try to give you best performance. In giving you the best performance, model will try to accommodate that outlier. In accommodating that outlier, it may overfit. That is the problem. Okay, impacted by outliers. What is second? Second is your model is very complex in nature. Your model is not simple in nature. Regression model are simplest, then decision trees, then random forest. These models are just before neural networks in terms of complexity of the model, in terms of interpretation of the model. So your model is not simple here. Okay. So these are some of the key advantages and disadvantages. Okay. Now somebody may ask you to compare XGBoost and LightGBM. So XGBoost and LightGBM, what is the comparison? XGBoost is old, LightGBM is relatively new. If something is old, you will have more documentation. If something is new, you will have less documentation. If something is old, you will have more people who have used it. So more support on the internet, more help on the internet. LightGBM new, less help on the internet. LightGBM is supposed to be faster than XGBoost. LightGBM is supposed to be, that's what the claim from the company is coming. LightGBM is performance-wise also better than XGBoost, but still XGBoost is more popular. These are some of the parameters on which you can compare these two. Now, an extension of this is XGBoost versus CatBoost versus LightGBM versus Gradient Boost, right? In this one, right, I will tell you guys, there is a detailed video. You can see the link here. Just watch that video where I have compared all these models in terms of performance, in terms of how they work with missing value outliers, in terms of what is new, what is old, for which you will get internet support, for which you will not get internet support. All these things I have put for all these models. Must watch that video. Okay. Then important hyperparameters for boosting, or for example, I will take here XGBoost only. I will just consider XGBoost only. Okay, so I will write here some of the parameters, very important parameters of XGBoost. For example, first I will go here and I will write max depth of your tree. What is the max depth you want? Then second thing, important parameter for XGBoost, and it will be more or less similar for other trees also. Okay, one thing can be learning rate, one thing can be number of boost, which means how many trees you want, number of estimators you can call it. One thing is you can call it column subsample, and one thing you can call it row subsample. Okay, row subsample. Okay, and another parameter that I'm writing here, alpha, lambda, and gamma. Okay, alpha, lambda, and gamma. Now, one thing you need to understand, guys, what is max depth? You already know. By default, this is 6 here, but how much you want to have? You can have 1, 2, whatever you want to have. Learning rate should be between 0 to 1. Number of trees by default, I think 100. This you can change how many times you want to boost. Column subsample is if I'm having 10 columns, then what percent of that should go in all the models? So you can have it 0.7, then only 7 columns go. Same fundamental in row sample. Suppose you have 10 rows, how many percentage you want to go in each of the models? So 0.7 means 7 rows will go. Alpha, lambda, gamma is parameters if you are using special kind of method for regularization in your boosting models. Okay, so these are important parameters that you need to talk in the interview. By talking this, you are making the other person understand that you have used this and you know how these hyperparameters work. And the last thing is how to tune the hyperparameters. Now, there are many hyperparameters. How do you tune that? So basically 2-3 approaches. One is called your grid search, other is called your randomized searched. Okay, so grid versus randomized. Now, how do you do it? In grid search, it will just create grid with all the input values that we give, and it will test on all these values, right? So this is one value, this is another value, combination, I mean, this is one combination, other combination. On all these, it will test in grid. And in randomized search, if you say that, you know, take this range, take the range of 5 to 10. So in this range, it will take some random value and it will try to optimize on those values and give you the best parameter. You can see a link for the video here. Detailed video on how grid search work and how randomized search work. Must watch if you are going to attend a data science interview. Okay. So how many things we have discussed, guys? 8 to 9 things we have discussed. Basically, they will try to understand if you know the fundamental of this algorithm, if you have used this algorithm, and if you will be able to use with the real data set. And by asking all these questions, right, interviewer will ensure you that you know all these algorithms and you understand the fundamental concepts. Okay. So let me know by likes and comments, guys. How did you like this video? I will come up with another interesting video. Please subscribe to the channel if you have not done yet. I'll see you all in the next video. Wherever you are, stay safe and take care.